All right. Hello, everyone. Welcome. This is a DigitalOcean Tech Talk. It's August 25th, 2021, and the Tech Talk is called Deploying Microservices as Kubernetes DaemonSets and Jobs. I want to welcome our viewers on different platforms. So welcome those of you here on Facebook. Welcome those of you watching on LinkedIn. If you're watching on YouTube, hello. And we're really excited to announce that we're on Twitch now. So if you're not following us there, please do. We're at DigitalOcean TV. So hi, my name is Kim Schlesinger. I am a developer advocate at DigitalOcean, where I focus on cloud-native technologies, especially Kubernetes. I live in Denver, Colorado in the US. And before working for DigitalOcean, I was a site reliability engineer for 3 years. I worked at a company called Fairwinds that builds and maintains clusters, Kubernetes clusters for many different clients. So I have a lot of hands-on experience with Kubernetes, and I'm excited to share some of that with you today. So that's a little bit about me. If you're joining us live in the chat, please say hello. Maybe tell us, who are you? Where do you live? And most importantly, what brought you to today's talk? So looking at the chat, hello, Luis from Brazil. It's nice to have you. Apton, it's nice to meet you. So yeah, even as I begin the talk, let me know, who are you? Where do you live, and what brought you to today's talk? I'm very curious. All right, so the agenda for today's talk, I'm going to do a general introduction. Then I'm going to provide an overview of what are Kubernetes daemonsets, and if you are someone who's deploying microservices or applications to Kubernetes, when might you use them? Then I'm going to give you a demo of some daemonsets, one that I've written myself, and we'll find one in the wild. After we talk about daemonsets and look at some examples, I will do an overview of what are Kubernetes jobs, and then do the same thing. I'll go through and show you a job that I've written, show you a job in the wild, and we can talk more about that. And then at the end, we will recap. So looking back at the chat, Apton, hello. You are a Node.js developer from Warsaw, Poland. That's great. Welcome. And then Rajesh, hello from India. It's nice to have you here. Pablo, hello from Spain. I always enjoy how international and global our audience is. Roberto from Dublin, and Sci-Fi Not, Alan from Denmark. Welcome. All right, so let's hop right in with the introduction. So this talk is called Deploying Microservices as Kubernetes DaemonSets and Jobs. And the last talk I gave was about another type of Kubernetes resource called deployments that help you deploy things. And the reason I developed these two talks was I've noticed in my own personal learning experience with Kubernetes that there's this big leap between when you do an introduction to Kubernetes tutorial and when you're actually trying to work with Kubernetes in production. And the leap is that in a lot of those introductory tutorials, you are deploying just individual pods, which is a good exercise, but is not how it's done in production in the wild. And what we really use when we're using Kubernetes clusters is we use these different Kubernetes types to create pods. So some of those types are daemon sets, deployments, stateful sets, and jobs. And so in my last talk, I talked about deployments. In this talk, I'm going to talk about daemon sets and jobs. So making that leap between just learning about Kubernetes and starting to understand it a little bit more deeply, and how do you use it in a production context. Oh, there it is. There's the daemon sets and jobs. So that's the leap that we'll be making during this talk. So the audience that I designed this talk for, it's for anyone who's running containerized workloads in a non-Kubernetes environment. So I'm not going to be talking about containerizing things or Docker. I expect that you already know even just a little bit about that. This talk is also anyone looking to gradually migrate to Kubernetes. Maybe you're working at a company or you're working on a personal project where you have containers deployed somewhere that's not Kubernetes, but you're curious about the system. This talk was also designed for anyone looking for information beyond those introduction to Kubernetes tutorials that I was talking about in that slide about the leap. And then this talks specifically about DaemonSets and Jobs. It's for both people who are maybe developers deploying to Kubernetes clusters, as well as people who are operators or admins of Kubernetes clusters. So maybe you didn't write the application code, but you maintain the Kubernetes cluster. This talk will also be good for you. I'm going to be doing a lot of demonstrating in a Kubernetes cluster itself. And so the versions that I'm using kubectl, the Kubernetes command line tool, version 1.21.2. You will want that version or higher. I have a running Kubernetes cluster for practice. I am using DigitalOcean's managed Kubernetes offering, but you can use Kind or whatever works for your budget. If you can't afford to spin one up in the cloud right now, that's all right. I recommend the Kubernetes and Docker project. The version of Kubernetes that I'm using in DOKS is Kubernetes version 1.21.2. And then there are three places where I'm going to be deploying from. So one is I have an example Kubernetes workloads repo that's linked here. So you can go there. We'll also be looking at a project by Weaveworks called Cured, as well as a project called Prometheus Stack, but we'll be digging into those a little bit more deeply in just a minute. All right, so that is the introduction. I'm going to look back at the chat and see who's there. Awesome. Okay, we've gotten a lot of comments. This is great. So Harman Deep, welcome. Nice to have you. Kandi from India. Rajesh, nice to see you. Mario from Estonia. Wonderful. Opara from Nigeria. Great. Joseph, hello. It looks like Node.js and Azure Microsoft developer in Serbia. Ooh, you're thinking about using Kubernetes. Thank you for telling me what brought you to this talk. I hope that this is helpful for you. Haroon from Pakistan, you're working as a solutions architect. Outstanding. Oh my gosh, there's so many comments. Okay, I'm going to keep going. Muhammad and MSMK Global. Oh, at MSMK Global, you're a cloud security engineer. We have George from the UK, Somalia from Mali, Darsharath from India, Lovekesh, hello. I've seen you on Cloud Chats, welcome. Shagaba from Nigeria, Shahid. We've got Tunse from Orlando, Florida in the US. Devarshi, hello. Oh my gosh. We've got Shahid from India, Jitendra, Rendito from Indonesia, Daimyo from Utah. We've got people from Morocco. Ulbrich is already using DigitalOcean Kubernetes. Great. I hope you get to see some things maybe you don't know about. Kyle from the US and Hashil from India. Welcome, everyone. Excited to have you. And it looks like we're from all sorts of different platforms, which is great. If you missed the beginning of the talk, we are now on Twitch, DigitalOcean TV, so you can follow us there and watch the live stream there. All right, back to the presentation. So I've done an introduction of just sort of what we're going to cover, talked a little bit about what tools I'm using for the demonstration, and now we're going to hop into it with an overview of Kubernetes DaemonSets. So a Kubernetes DaemonSet is a tool you can use where you generate one copy of a pod that goes on every single node. So if you have been a systems administrator before, or you've used Linux systems extensively, DaemonSets used to be called in those systems like agents or daemons. And so a daemon is like an automated tool that you install on something and it sort of runs in the background. And so I have a picture of these robots to sort of symbolize that. Like you write maybe the software for a DaemonSet, or you install software for a DaemonSet, and it runs in the background quietly, and it does something for you that you don't have to think about all that often after configuring and installing it. So I want to just look and see what kind of DaemonSets are pre-installed in a DigitalOcean managed Kubernetes cluster. So this is my command line. I have a DigitalOcean Kubernetes cluster, and I'm just going to look at the nodes. So I have three worker nodes. They are called basic nodes, and you see they each have an individual hash at the end. So if I have three nodes running, and if I have some DaemonSets running, I'm expecting to see one pod for each DaemonSet on a node. So let's see what DaemonSets we've got pre-installed. I haven't installed anything special on this this Kubernetes cluster. So if I do kube control, get ds for DaemonSet, and I'm going to say all the namespaces with that capital A. All right, so it looks like I have a lot of DaemonSets that are running. They're all in the kube system namespace, and that's the namespace that we often use to put things that either like the company that's managing our Kubernetes cluster is taken care of, or services that help Kubernetes run, that Kubernetes installs itself. So we have a DaemonSet called Cilium, called CS-DO node, DO node agent, and kube proxy. So kube proxy is something that Kubernetes installs. It allows nodes to talk to one another. But let's see if we can see the individual pods running on each node. So if I say kube control, get pods from all the namespaces, and I'm going to focus on, let's do CSI-DO node. All right, so in these pods, you can see I have 3 pods running that have been generated by the CS-DO node DaemonSet. So it's 1 pod per node. Those things are running in the background. I may not ever have to look at them, especially if I'm a developer deploying into a Kubernetes cluster. And so those are the DaemonSets that come pre-installed in a Kubernetes cluster set up by DigitalOcean. If you're using Kind or Minikube, or you're using a managed service from another cloud provider, you're also going to be able to see some DaemonSets that get installed by default. So I recommend you check it out and see what's there. So DaemonSets, they're these things that run sort of in the background, 1 pod per node. They are often used for these purposes. The first is cluster storage. So setting up something where data gets saved on the actual virtual machine that's running your Kubernetes node. Another thing that DaemonSets are used for is a log collector. And so what's going on that machine, the logs get collected and stored on the node and probably shipped somewhere else. So you can see those logs. And then the last main thing that DaemonSets are used for is node monitoring. And so gathering information about the computer and helping you set up observability, setting up monitoring and alerts. So again, kind of in the background. So when I was a site reliability engineer at my last job, I never wrote software for a DaemonSet, but I configured and installed a lot of DaemonSets on a Kubernetes cluster. One that I remember doing a lot was we used Datadog for monitoring and alerting at my last job. And Datadog, using their Kubernetes software packages, have a lot of DaemonSets running. They have agents running that's collecting data and then shipping it off to Datadog. So you can log into their platform and see the data visualized in your browser. So you do a lot of configuring and installing of DaemonSets. And then another thing that you might want to learn more about DaemonSets for is if you have to debug during an incident. So sometimes something's going wrong with the DaemonSet, or you notice oh, a DaemonSet can't be scheduled on a node. Maybe you're running you've exceeded the maximum number of nodes that you can have in your Kubernetes cluster. So it's good to have some information about DaemonSets so you can debug during an incident. So that's the overview of Kubernetes DaemonSets. If you were to take away one thing, I would recommend it's that image of all of those little robots. DaemonSets get installed, 1 per node, and they run helpful things that you don't have to think about too often, but hopefully give you information about your Kubernetes cluster or the applications working in your Kubernetes cluster. So let's get into the DaemonSets demo so we can actually see what does it mean to create a DaemonSet using Kubernetes manifest, and what does it mean when you install one? What does it look like? So I have 2 examples, and the first one is called the show node name DaemonSet. And this is something that I've written. This repo is available for you. It's at do-community example k8s workloads. And if you go to the DaemonSet directory, I have some instructions about what this little piece of software does. But let's actually just hop right into the Kubernetes manifest. And I'm going to increase the size on this. All right. So I like creating things in Kubernetes using YAML manifests. It's the first step to doing infrastructure as code so that this code lives somewhere where somewhere else could see it. Changes get tracked by Git. But this is a manifest for a DaemonSet, and we see the kind, it's DaemonSet. If it was something else, if it was a deployment or a pod or a service, the kind would be different. So we've got this DaemonSet. The metadata, the name of the DaemonSet is node name. And we have some more things like selectors. But I want to go down to the container that the DaemonSet is going to set up. And so the DaemonSet is going to create a container called show node name daemon. That container is going to use the BusyBox image. BusyBox is something that I see a lot in tutorials and that people use. It's a nice image where you can spin up a container with some utilities in it, like wget, and you can sort of ping things within your cluster and look around your cluster and have access to a shell really easily in your cluster. So the DaemonSet's going to create a pod. The pod's going to create a container using BusyBox, and then it's going to run this set of commands. And so it's going to say this daemon is running on node name, and it's going to pull the environment variable of node name and show us that. And then it's going to say, here's a cat. And then that container is going to sleep for a while, and then it will repeat that process. And so what I've done is I've used this thing called the downward Kubernetes API, and I have set this environment variable node name, and it's accessible with that variable name, node underscore name. And so every time I look at a pod, it should tell me the node name of the computer that it's running on. So let's deploy that. I'm in my example K8's workloads directory. I'm going to change into the DaemonSet directory, and I'm just going to look. Okay, I have that README and I have that DaemonSet file. Cool. So what I'm going to do is I'm going to say kubecontrol apply the file daemonset.yaml. And it says, hey, I created a DaemonSet called node name. So let's check that out. Kubecontrol get DaemonSet. Let's not do all namespaces, just the default namespace. Cool. All right, so I have a DaemonSet called node name. There are 3 copies of it running because I have 3 nodes running. So let's see the names of those nodes. Kubecontrol get nodes. Cool. And let's say kubecontrol get pods from the default namespace. All right, so for the 3 nodes, I have 1 pod on each node. And let's actually look at the logs. Kubecontrol logs for this pod and see, hey, okay. So that little script that I wrote where it's pulling the node name and then saying, here's the cat. So it says this daemon is running on node basic nodes 8VKF6. So it looks like that pod is running on that node. Let's look at the logs in this pod and see if they have a different node name. So kubecontrol logs. Excellent. So it says this daemon is running on node basic nodes 8VKFE. Okay, so that node is running on this, or I'm sorry, that pod is running on this node. And let's do the last one just for good measure. So we're expecting to see this middle node with FA at the end of the hash. So kubecontrol logs, that node name. Hey, there we go. All right, so this DaemonSet doesn't do anything. It's not like a utility I would actually want to use, but for demonstration purposes, what I'm trying to show is that a DaemonSet creates 1 pod per node, and you can see the name of the node there, so we're proving that that's working. So another nice thing about DaemonSets is that as you scale up the size of your cluster, it's going to increase the number of pods with the number of nodes. And so what I'm going to do is right now I have 3 nodes running in this Kubernetes cluster. I'm going to scale it up to 5. And this just requires some command line work. And I need to pull up my notes for that. So I'm using DigitalOcean Kubernetes. The first thing I need to do to scale up is get the, oh, I keep showing you the wrong thing. There we go. I just have to arrange some windows real fast. Beautiful. All right, first thing I'm going to do is I just need to get some information about my Kubernetes cluster, like what's the name of the cluster and what is the name of the node pool, because that's the thing I want to scale up. So I'm using Doctal, which is the DigitalOcean command line tool. I'm saying Kubernetes cluster list. So it's going to show me information about my Kubernetes cluster. All right, so I have this long, like unique ID. I have this name of my cluster. It's DaemonSet Jobs demo cluster. And then it looks like it's off the screen. There we go. You can't see it because it's so big, but the node pool is called basic nodes. Let's make that a little smaller. So maybe we can get that all in one line. There we go. Beautiful. And then the command using Doctal to scale up your cluster, you say Doctal Kubernetes cluster node pool update, node-pool update. And then you pass in either the cluster ID or the cluster name. I'm going to pass in the cluster name because I can read that. And then you pass in the name of your node pool. Mine is basic nodes. And then you use this count flag. And so I have 3 nodes running. I want 5 nodes to be running. All right, looks like that command worked. But it's going to take a couple of minutes for those nodes to spin up. So what I'm going to do is I'm going to get the list of nodes, cube control, get nodes, but I'm going to watch that. And while I'm doing that, I'm going to look back at the chat and see if there's anything new in here. I don't think I said this, but I'll take questions at the end. And if I remember in the middle, I can take questions. So, all right. We've got some folks. We've got Hung from Vietnam, who is a blockchain developer. Welcome. Happy to have you here. We've got Simon from Ghana. Welcome. And then Sci-Fi Not said, can you share the PowerPoint? And the slides will be shared on the Tech Talk information page at the end of the presentation so that you can follow along. So that will be up soon. All right. So looking back, okay, I've got 1, 2, 3, 4 nodes. Cool. That's enough for demonstration purposes. So I'm going to cancel out of that. So if I say cube control get nodes, oh, still only 3. I think my nodes are still spinning up. It takes a little while. But what we're going to do is we will come back to this and take a look and see if those daemon sets are going to be added to the pods, or each pod from the daemon set is going to be added to a node. So, all right. So we've got back to the comments. Rohan, hello from India. Masood, I hear your frustration that you need to spend money on a Kubernetes cluster. That's true if you're using something like DOKS, but I highly recommend checking out the Kind project, Kubernetes and Docker. If you have Docker Desktop installed on your computer, you can create a local Kubernetes environment that doesn't cost you anything for a cloud provider. Another alternative to Kind is Minikube, and those are great things to use when you're practicing things, like if you're following along with the talk. So that's one way you can get around the costs, but yeah, it can be frustrating with the costs. All right, cube control, get nodes. Okay, woohoo! All right, I've got 1, 2, 3, 4, 5 nodes now. So if I cube control, get pods in the default namespace. Great. So you can see I have these 2, they're like brand new pods. They're 19 seconds and 26 seconds old. And when I scale up the size of the Kubernetes cluster by increasing the number of secondary nodes, the daemon set is going to make sure that there is 1 daemon set node on every single pod. So that's one of the benefits of those daemon sets. All right. So that was example 1, how to use a daemon set, my show node name daemon set. You can get that code and that Kubernetes manifest at that do-community repo. But now I want to show you an example of daemon sets in the wild. Because like I mentioned earlier, if you are someone who's operating a Kubernetes cluster, you might not write code that gets run as daemon sets, but I'm pretty sure that you're going to be interacting with daemon sets. Maybe you're installing something that some other company wrote that's a tool that you're going to use on your cluster. So the example that we're going to use for daemon sets is a tool called Weaveworks Cured. So let's go look at that GitHub repo. All right, that's pretty big, but that's okay. So I'm going to scroll down. So Cured, it looks like it stands for Kubernetes Reboot Daemon. So it's got daemon in the title, which makes me think there's probably a daemon set in here. And in the introduction, it says Cured is a Kubernetes daemon set that performs safe automatic node reboots when the need to do so is indicated by the package management system of the underlying operating system. So this software, there's one copy of the pod running on a node, and it's checking to see, is the operating system giving me cues that this computer needs to be rebooted? So there's some information about Kubernetes compatibility. But what I want to do is, just like I showed you the YAML manifest for the DaemonSet that I created, I want to find a YAML manifest for the DaemonSet for Cured. And so it's kind of hidden away, but I'm going to go to tags. And then I want to grab their most recent release, which right now is 1.7.0. And they have some information about what was changed in this release. If I scroll all the way down to the bottom, in the asset section, they have their YAML manifest. So I'm just going to click on that. And it looks like it got pulled up over here. And so just looking through this, there's more than just a DaemonSet. This is a complex piece of software, so it needs some RBAC roles. So we've got this cluster role for Cured, and it's saying you have access to the node resources, pods, apps, DaemonSets, and evictions, and you can do these verbs on those things. We see more information about the role binding, creating a service account. But here's the DaemonSet. So it's like the other DaemonSet that we saw. It's got the kind DaemonSet. It's called Cured. It gets installed in the kube system namespace. It's got something for the update strategy. It's got the spec. And then down to the containers part, we're pulling from Weaveworks Cured image to create the container. And it looks like they're also using the Kubernetes downward API. They're setting an environment variable called Cured node ID, and then that probably gets used. And then there are all of these optional commands that you can pass in. We're just going to do the default. So let's get to this. Okay, so I have that saved as cured.yaml, and so I'm going to apply that now. I installed this last night to practice, so there are still some things there that already exist, but let's take a look and see, do we have kube control, get DaemonSets from all namespaces? All right, so we have the Cured DaemonSet running. Because we have 5 nodes, there are 5 pods, 1 pod on each node. And if we say kube control, get pods from every namespace, and we'll grep for Cured. All right, so we've got those 5 Cured pods running on each DaemonSet, or I'm sorry, on each Kubernetes node. So this is an example of a Kubernetes DaemonSet in the wild. If you're actually installing this cool piece of software, I wouldn't just grab the YAML. If you can, I would use the Helm chart, which will make it a lot easier for you to configure, but that is one way that you can do it. So let's go back to the presentation. I will present this. So what we just did is we looked at a DaemonSet in the wild, this cool tool by Weaveworks called Cured. So check it out if you're interested. So one final comment about DaemonSets. If you don't do a whole lot of configuration and you set up a DaemonSet, you're going to get 1 pod per Kubernetes node. But you might be saying, like, I have a pretty complex Kubernetes cluster. Maybe you have different compute types that are running different kinds of workloads, and you only want this DaemonSet that you're installing to run on specific nodes. You can absolutely do that. And the way that you do that is you use the node selector field in the DaemonSet configuration. And you say, I only want this DaemonSet to be installed on nodes with a certain label. And so a good example of this is the DaemonSet called DO node agent. So if I say kube control, get DaemonSets from all namespaces. And this line here is the DO node agent. And you can see in this little description that only gets installed on Kubernetes nodes that have an operating system of Linux, or at least have that label on them. So you can specify where DaemonSets go, where the daemons go, using the node selector. Beautiful. All right. Back to the presentation, if I can find it. Oh no, this happened to me. This happened to me earlier. I like put my Chrome window somewhere and I'm not sure where it went. That's okay. All right. Well, taking a look at some comments. I've got a couple. I'm gonna save some of them for the end. Oh, I like Kyle's comment. So yeah, if you have Raspberry Pis, you can use those to set up a Kubernetes cluster. And instead of having Docker containers function as your nodes, you can actually have a different Raspberry Pi functioning as your node. That's very cool. Joseph says, is there a way to scale nodes and pods automatically? There are tools like Cluster Autoscaler that can help you do that, where you set thresholds where your cluster will scale up and where it will scale down. We don't have enough time to go in that now, but it's something to look into. Hung, I see your question. I will talk about that at the end. And then Harmon, isn't it nice to see some nodes running? Yeah, it's fun to actually see like Kubernetes clusters in action. So beautiful. All right, I need just a moment to find my presentation or spin it up somewhere else. I must have like another window. I don't know where it is. All right, there we go. We'll go through the whole thing. Okay, so DaemonSets. We just wrapped up the DaemonSet demo. And now we're going to hop into a discussion of what are Kubernetes jobs. So in Kubernetes, there's a resource called jobs. And the purpose of that resource is to create a pod that will run once. And so the image I picked for this was reusable water bottles, that they are not necessarily intended to be used over and over and over again. They have application for one use, although you can, of course, reuse those kinds of water bottles. But jobs are very different in that deployments and daemon sets and a lot of things in Kubernetes, you set it up so that there's a controller listening and looking and saying, hey, you have a daemon set, you want one pod per node, and I'm going to make sure that's true. Or if you have set up a deployment, let's say you say, I want 3 replicas of that application running, Kubernetes will say, I need to make sure there are 3 replicas of that application running at all times. And so jobs are very different in that they're just one-off. You spin up a job, the pod runs once, and then it's done. And that's what you use it for. And so you can set up Kubernetes jobs in a few different ways. The first is one shot. So you might say, I'm going to have this pod run once. I just need to do this one activity one time, and then it's over. And so an example of that might be a database migration. You need to change the schema, or maybe you're moving from one version to another. And so you could create a Kubernetes job that handles that database migration, and then it's done. It doesn't continue running after it's over. The other thing jobs can be configured to do is parallel fixed completions. And so you would have multiple replicas of that pod running, and they could be finishing on their own, but they're running at the same time. And then the last one is the most complicated one, work queue with parallel completion. And so that's like if you have something like RabbitMQ or some queuing system that's sending you data, and then your job pods could be handling the task that needs to be done, sent to you from the queuing service. So jobs, I think, are kind of falling out of fashion in Kubernetes. And the reason is that they're often part of the operator pattern. Like I don't see a whole lot of one-off Kubernetes jobs. So the operator pattern is when you create software that leverages the Kubernetes API and does its own cool thing. Same thing with custom resource definitions. And so in Kubernetes, a CRD is when you create a Kubernetes resource like pods or daemon sets, you create your own thing, and the Kubernetes can access and create that resource over and over. And then the last place where I have seen jobs is patching. And so you're actually using that job to go in and update existing software that's running in your Kubernetes cluster. So that's those are where I've seen jobs in the last couple of months in Kubernetes. So you might be asking yourself, Is a Kubernetes job a cron job? And the answer is no. Kubernetes has its own cron job type. So if you do need a job to run on a schedule, you can absolutely do that. And sometimes Kubernetes jobs are used to spawn a set of cron jobs, but we're not going to cover that use case right now. So that was the overview of Kubernetes jobs. Think of the image of the plastic water bottles, one use. They were designed to be run once and then they're done. And so let's actually let's look at an example of a Kubernetes job. And the first job is one that I put together. It's called Generate UUID Test Data Job. And so if we go back to the do-community example workloads repo, and if you go to job, I have a little job here. And so what this job does is it generates universally unique IDs. And I borrowed this from a DigitalOcean tutorial about how to use UUID gen on a Linux machine. So if you're curious about what's going on here, this tutorial will tell you. But what this job does is you create the job, it spins up one pod, and then what the pod does is it generates some UUIDs and then concatenates those with @mailinator.com. And what I'm imagining you might use this job for is, let's say that you have a staging or a test Kubernetes cluster where you need to run integration and unit tests, and you need lots and lots of test data. Like email test data. This would be a great way to do that. So you spin up this pod, it creates a bunch of UUIDs and makes them into email addresses. And then what this does is it saves those. Let's see if I have the instructions here. Oh, it doesn't look like it. Let's look in the manifest then. It saves those test ID addresses in the temp file in a file called emails.txt. And so one thing that jobs can be useful for is if you have to generate something that requires a lot of compute power that maybe you want to do at night, or you just want to do once in a while, like generate UUIDs. In the book, Kubernetes Up and Running, the authors give an example of a job that is generating SSH keys. Like that's compute intensive, and like just have a job do that every once in a while. So that's what this job does. And let's see it in action. All right. So I am in my DaemonSet directory. I'm going to change into my jobs directory, or just job. And I'm going to say, actually, before I do that, let's just see if there's any jobs running in the DOKS cluster. So kube control, get jobs from all namespaces. No resources found. So no, there are no jobs currently running in this Kubernetes cluster. Let's change that. So kube control, apply the file that I've called job.yaml. And it says, hey, I've created a job called UUIDgen. So kube control, get jobs. Awesome. So in the default namespace, I have this job called UUID. It hasn't completed yet. If we look at the code, I meant for that to be 10 minutes, not 1 minute. This job completes after 60 seconds. So let's see if we can catch it before it's done, because the logs will be a little harder to get. So if I get pods from the default namespace, you see that UUID pod is running. And if I kube control logs for that pod, so you actually see all of the things that are happening. That image creates an Ubuntu container, and then I'm installing UUIDgen and then doing all the stuff. But at the end, I've asked for that container to cat the emails.txt file. And so you can actually see those are the 10 unique IDs plus emails at the end. So let's see if that job is still running. Kube control, get jobs. It looks like it is completed. So I think if I look at the pod, it says it's completed. So that pod is done. That job is over. It happened once, and it's ready to go. And so I won't be able to access the logs for that pod since it's not running. Let's confirm that that's true. Kube control logs, and then the name of the pod. Oh no, I'm wrong. The logs are still available. So at some point, maybe they won't be. So now what I'm going to do is I'm going to say kubectl delete job UUID gen. So that job has been deleted, and there should no longer be the UUID gen pod. It's gone. So that's an example of a job that won off. I'm going to just take a peek in the comments and see if there are any questions about jobs here. All right. Joseph says, how would one control the queue jobs pod? Which one would get the priority if two jobs were to run? And can the one-time job and queue job be combined? Those are good questions. I actually just don't know the answer to that off the top of my head. So let's take a look at the Kubernetes documentation for jobs and see what we find. So kubectl jobs, not kubectl, Kubernetes. Kubernetes, you can tell I've been at the jobs docs a little bit. So this is the Kubernetes documentation. It's good. I think it's getting better and better all the time. So if we scroll down, we've got the example job here. They're looking at the output, writing a job spec. Okay, so this is the section that you'll want to look at, the parallel execution for jobs. It'll give you some information about the non-parallel jobs, the jobs in parallel, and then working with a work queue. Working with a work queue is super advanced. It's not something that I've done all of that often. So this is where I recommend you look, Joseph. I'm sorry, I don't know off the top of my head. And then the second part of the question, can a one-time job and a queue job be combined? I'm sure you can do one of those things. You're like, this job is going to kick off this other job, which is related to a work queue. So it's probably possible. All right, back to the presentation. So we looked at the job that I made, generating UUID test data. Let's look at a job in the wild. I'm so excited. And so what we're going to be looking at is a job from this big project called Prometheus stack. So we're going to go to that GitHub repo. Okay, so first thing, this is in the Prometheus community GitHub organization, and then it's in Helm charts. And so when we were looking at Weaveworks Cured, I was just showing you vanilla YAML. There was nothing special about that YAML. Because this is a Helm chart, we'll still see the YAML manifest, but we're going to see like the double curly brackets for Go templating. So you can pass in values dynamically. So it's going to look a little bit more complicated, but we'll figure it out. So in Helm, you keep your manifests for Kubernetes resources in the templates directory. So let's look there. Okay. And I'm looking for something that says job.yaml. So Prometheus operator, that sounds like maybe it'll have something. Okay, so I see cert manager, cluster role binding, deployment. I don't see any job. Let's go into the admission webhooks directory. I see job patch. Okay, cool. So this file is called job-createsecret.yaml. And so this is the templating feature where you can pass in values in another file and Helm will render them. But even with all that stuff, I still see, okay, there is Kubernetes job. And it's got a name, it goes in the namespace, there's some annotations. I'm curious what the container looks like. Okay, so they have a create container. Ooh, they have, okay, so that's the name, and they have the image, and they have another image. And then the arguments they pass that container are create, and then other arguments. Okay, I'm gonna scroll down. Okay, I don't entirely know what that's doing. But based on the context clues in this project, here's what I think is happening. So we have, we're in the Prometheus operator, we're in the admissions webhooks, and I think they probably had to do some updating when they created a release. And so they have this job patch directory, and they have these two jobs, and it looks like one creates a secret and one updates a webhook. And so this is a good use case for a job. You have software that's maybe already running in your Kubernetes cluster. You want it to continue to run, but maybe you need to create a secret or you need to amend something. A job is something, if you're doing one of those one-shot jobs where you can deploy it into your cluster, the job will handle the operation and then it'll be done. So that is an example of a job in the wild. I will not be deploying that into the cluster. It's a little too complex for what we're doing now, but feel free to poke around that project. All right. So that was our example in the wild of a Kubernetes stack. So just a reminder, jobs in Kubernetes can be set up to be one shot. One pod does one thing and then it's done. Parallel fixed completions, you have multiple instances of that pod running and they're all working aside one another. And then work queue with parallel completion, that's where you're setting up, you have a work queue that's giving your job some information and the job takes care of the task at hand. All right, so we're at the end, we're ready to recap. So in the beginning, I was talking about how I have seen a lack of good information bridging the gap between introduction to Kubernetes materials versus how do you actually get software running on a Kubernetes cluster like a professional. And so some of the ways that you can create pods in Kubernetes are through deployments. That was the talk I gave a month ago. You feel free to look that up. Today, we talked about DaemonSets and Jobs. And another way you can create pods is with stateful sets. So in software, a daemon is hopefully a friendly piece of software that you install and sort of runs in the background and does automated tasks for you. So you like friendly little robots. Often in Kubernetes, you are configuring and installing software that runs as daemon sets, and therefore you are debugging during an incident. Unless you're doing some really advanced work at a large company, you probably aren't going to be writing a whole lot of daemon sets on your own. Kubernetes jobs, on the other hand, are for one-time use tasks. And we often see them as part of a larger whole. And so maybe it's part of the operator pattern, maybe it's part of a custom resource definition that you're building out, or maybe you're patching some existing software like we saw with those Kubernetes stack jobs. I think I already went over that. And so in the recap, I would really love to hear from you all. What is one thing that you learned, and what's one thing you'll do differently after watching this talk? So if you're live in the chat, tell me what's one thing you learned, what's one thing you'll do differently after watching this talk. While people are responding to that prompt, I'm going to go back up to a question that I said I would answer at the end. So let me find that. All right, so Hung's question is very specifically about DigitalOcean Managed Kubernetes. So Hung says, what is the highlight of DigitalOcean Managed Kubernetes compared to AWS EKS? So I've used both DigitalOcean Kubernetes and AWS EKS. So one of the highlights is DigitalOcean. So if you're already using DigitalOcean Droplets or App Platform or any of our other software, you can pretty easily spin up a DigitalOcean Kubernetes cluster. The control plane in DigitalOcean Managed Kubernetes is free. We don't charge you for the compute usage there, and I think that's different than AWS EKS. DigitalOcean as a company and the products we make were all built on simplicity, and so I think you saw using Doctal, like how fast you can spin up a Kubernetes cluster. It can go really, really fast, and also if you're not super familiar with command line tools, you can do all of this from the UI. So this is my cloud account at DigitalOcean. And if I go to the Kubernetes tab, this is the cluster that I spun up for this demo. And you can see things like the nodes. I could add a node pool from here. I could scale this down. You can get some insights that are really nice. This must be like when I'm installing software, increasing the number of nodes. So I would say the simplicity, the cost, we're also really straightforward about the cost. We'll tell you when you're creating your Kubernetes managed cluster in DigitalOcean, what it's going to cost you each month. So even though it may be pricey, you know upfront how much it's going to cost. Let's see. Yep, so you can see this cluster has projected cost of $100 US per month. So to summarize, you can spin up a cluster real fast in DOKS. The control plane is free, and the simplicity of using DigitalOcean Kubernetes. All right, so I want to know one thing you learned. What's one thing you'll do differently after watching this talk? Hoping to see some comments. All right, Harmandeep says, Kubernetes Daemon explained very well. Finally getting more motivated to use Kubernetes. I'm a fan of DigitalOcean, so good. I hope this was helpful. I had used DaemonSets in the past before preparing this talk, but getting ready to teach it helped me really hone in on what's going on with Kubernetes DaemonSet. Let's say Tunke says, we're using DigitalOcean managed Kubernetes for production, and it's simpler. There you have it. And then Joseph, this is great. I have learned that I will probably be using Kubernetes. I would focus more on making apps software scalable, and I will also give that jobs page a good read. Thanks for the lecture. Well, it was a pleasure to have you all. Cool. Well, to finish things off, again, this slide deck will be available on the Tech Talk page, hopefully later today. The resources that I used to prepare for this talk are the Kubernetes docs. The DaemonSet Jobs documentation are great. The book Kubernetes Up and Running was written by like the big three, Kelsey Hightower, Brendan Burns, Joe Beda. It's a really good book. I highly recommend it. If you're curious about that UUID generation trick, the DigitalOcean tutorial on that is outstanding. And then DigitalOcean has some good Kubernetes materials. One is Kubernetes for full stack developers. So that actually takes you through building a Node.js app, containerizing it with Docker, and then deploying that on Kubernetes. So if you're more on the software side of things, that would be interesting. And then if you're interested about DOKS, our managed Kubernetes offering, we have docs and a good quick start. And Kyle, one last thing that I learned about using jobs to do work across the cluster. Really well said. Yeah, you can use jobs as like a literal tool to be like, oh, I got to fix this thing, or I just need one thing to happen once, and Kubernetes job is a good use case for that. All right, thank you so much, everyone. You can find me on all the social medias at Kim Schless. That's a link to my DigitalOcean community profile. It was a pleasure talking with you. Thanks for interacting. It was great to see you all on Facebook, LinkedIn, YouTube, and Twitch, and we'll see you soon. Take care.